Hello. Today I'll be presenting experiment 2 on IP addressing and subnetting. So the topics which we'll be covering is the binary conversions and IP address classification and subnetting calculations. So the question one is binary to decimal and decimal to binary conversions. And so we'll be first converting binary to decimal, which is like the number is given here. So what we do is like we convert a binary IP address to decimal, each where each octet is converted separately by adding the place values where we have ones, and the first octet which is like double one triple zero triple zero, which is equal to 192, and the second it is like 101 01000, which is equal to 168, and the last two are both 1. So our answer will be 192.168.1.1. As you can see, that's the answer for the first part, which is like binary to decimal conversions. So when we see about decimal to binary, we'll be we convert that 172.16.254.1 to binary by dividing each number by 2 repeatedly and writing the remainders, and the final answer is shown on the screen. As you can see, this is the answer for converting this decimal address to binary address. So let's move on to question 2, which is nothing but identifying the class and caste types of given IP addresses. So let's see. For question 2, we identify the IP address characteristics first, then the address, which is 10.255.23.1, is a class A because its first octet is 10, which falls in the 1 to 126 range. So we call it a class A, and its private address and it uses unicast communication. The address 224.0.1.1 is class D, which is used for multicast purposes. So let's move on to the next question, which is nothing but determining the broadcast and network addresses. So we are given the IP address 192.168.1.70 with subnet mask of 255, 255, 255, 192. So what we do is like we are given an IP, and with subnet mask also it is provided, which is /26 network. To find the network address, we perform a bitwise AND operation. The network is, as you can see, 192.168.1.64, and the broadcast addresses where all the host bits are set to 1, which is equal to 192.168.1.127, and this gives us 62 usable host addresses. And as we can see, it's like usable host, it's like 64, and we just neglect it with 2 because we exclude the network and the broadcast addresses, so the final answer will be 62. So let's move on to question number 4, which is nothing but subnetting and borrowed bits. So what we do in question number 4 is nothing but it asks us to create subnets by borrowing 2 bits from network 1, which is nothing but 192.168.1.0/24. Borrowing 2 bits gives us 4 subnets. So the new subnet marks become /26. Instead of /24, it becomes /26, or it becomes 255.255.255.192, where each subnet has 64 addresses with range, which is shown on the screen. As you can see, there are like 4 different subnets. Since we are borrowing 2 subnets, so it becomes 4, and we are getting the network address and the broadcast addresses. So the next question, it's subnetting to meet the host requirements. So what we do in the fifth question is nothing but we need to support at least 50 hosts. We need to at least support 50 hosts. So we need 6 hosts per bits, because 2 to the power 6 equals to 64, which is nothing but 64 addresses. Giving us 62 usable hosts, the subnet mask will be around /26, or we can call 255.255.255.192. So that is the answer for the fifth one. And so the next question will be identifying the casting types. So Regular addresses like 192.168.10.15 are unicast, and cast like these, they are called as limited broadcast, which is nothing but class D. And class D addresses starting with 224, which are uh, cast addresses. So the next question will be moving. So again, it's like identifying the typecasting. Is a repetitive question. Typecasting. Okay, for the question 7. Okay. So here we are design a network scheme with 5 subnets from 200.53.3.0. Since it is a class C, as you can see from the number, which is 200, the default mask is /24, and we borrow 3 bits to create 8 possible subnets, and the new subnet mask is /27, or we can call it 255, 255, 255.24, where each subnet has 30 usable hosts. The 5 subnet ranges are shown on the screen. So I think we have completed all the 7 questions. So we have successfully completed experiment 2, covering IP addresses, network addresses, private addresses, classes of address, subnetting, and by this we'll be covering classification and subnetting calculations. And thank you for